Good afternoon, everyone. On behalf of agricultureinformation.com, I like to invite the speaker, Professor Lalit K. Vashishta, who will talk about Nanoporex Nanobubble technology for sustainable agriculture. I now request the speaker to begin. Thank you.
Yeah, very good afternoon to the agricultural community. Uh, Today I'm going to be talking on a very unique subject for the Indian agriculture. Not much has happened in this country, and we are trying to introduce this with very good results. We have been discussing about nanobubbles, so the flow of the presentation will be just a second. The flow of the presentation will be basically giving you an insights into what is nanobubbles and then how it is beneficial to agriculture. We have 35 years experience in the process technology, and water treatment is one of our fortes. And from there, we have gone into agriculture, where we discuss mainly water management, soil rejuvenation, irrigation technologies for agriculture and farming. So there is something about myself. I am running this business since 1989. It's almost 35 years now. And I'm a professor of practice at the MG University Environmental Science, Kottayam, Kerala. And I run a few startups. So what are the drivers for developing this technology? This is happening all over the world. Now, agriculture accounts for 70% of the global freshwater withdrawals. You are aware that agriculture is the biggest consumer of water when it comes to management of water in this country or anywhere in the world. Demand for chemical-free solutions is being sought by the farmer because the consumption of the fertilizers is very high. Over the years, we have seen a decline in the soil health. Then we have enhanced crop yields, which is a common requirement of the farmer so that he can improve his profitability, and sustainability and circular economy goals, which are required in agriculture. And finally, the climate change and carbon footprint reduction is what we are targeting as a company. So first we will come to understand what are nanobubbles. When you put a bubble or a gas into water, you must have seen when you are drinking Coke or you take a sipper and blow some air into the water, bubbles come, big bubbles come, and they disappear within no time. So when you can engineer these bubbles in such a way, you can put a charge to these bubbles in such a way that they do not come out. They become so small that their buoyancy effect is almost negligible. They don't float up and they remain inside the water for days together. So these are normally in the range of about 10 to 50 nanometers, 100 nanometers. That is the range. These are invisible to the naked eye. So when we create nanobubble water, it's absolutely, you cannot see any bubble in the water. Average size 100 to 150 nanometers. You can see what I just mentioned as a property. Ordinary bubbles go up, micro bubbles, they stay for some time and then disappear. Nano bubbles continue to stay and you cannot see only, but you can check the oxygen level of that water. That goes up very drastically, which is required by the farmer, by the plant, and we'll give the reasons why it is beneficial for the agriculture. So this is something to show or more on the aspects of the physical bubble. It's having a pressure of about 60 bar from inside because of the surface tension, and it has a reactive oxygen species at the surface. So technically at the core there is a nanobubble negatively charged on the surface, and then you have at the core all around the periphery you have a negative charge. So gas transfer mechanism is high surface area to volume ratio. That means nanobubble possesses a very high ratio for gas exchange to liquids. When nanomoles contact a liquid, gas molecules diffuse across the bubble liquid interface driven by the concentration gradients, because inside there is very high concentration of the gas, that is oxygen. Oxygen slowly diffuses out and it goes to the soil, and also because of the cavitation effect, the soil becomes open. We'll give more details pictorially down the line. When it comes to technical properties, 150 200 nanometer diameter with high surface charge, it has got a zeta potential of -30. I'm talking a little bit of technical in the beginning. We'll go to more of case studies in the next few slides. It has got an 85% oxygen transfer efficiency. Why I'm telling you is because there is a lot of science in developing this. The whole equipment has cavitation, has charge, has certain principles on which we create these nanobubbles. It elevates the oxygen levels from 7 to 9, which is normal about 6 to 7 ppm, to around 15 to 30 ppm in irrigation water, which enhances the oxygen transfer efficiency by 85%, promoting aerobic root respiration. That means more oxygen at the root level, you get better respiration at the root level. It improves the oxygen reduction potential from 200 millivolt to 350 to 450 millivolt, creating optimal conditions for beneficial microbiota and nutrient cycling. And last is it increases the ODR, that is the oxygen diffusion rate, by 9 to 10% in the root zone, mitigates hypoxic conditions. Now, hypoxic conditions can create a lot of pathogenic uh, uh, zones for the plant, which can affect it negatively. So this is what is avoided using nanobubble water. It has got a history. First research was done in 2010. Lab validations happened. Then we had 2016, 19. We were in the early horticulture wins we saw. Then 2020 research breakthrough happened. In 2025, we are now coming in Maharashtra, Punjab, Tamil Nadu, demonstrations and drip irrigation. Water soil plant triangle, water chemistry. Like I told you, what higher DO, that is dissolved oxygen, and ORP keeps irrigation, prevents biofilm formation and emitter clogging in the drip lines. That means it helps irrigation wherever drip irrigation is happening. You get scaling in drip irrigation. That scaling is stopped. It remains clean. The pores remain clean. So it affects all these things positively. The soil health, from 25.8 to 42.6 microgram per centimeter square per minute, better soil structure, water infiltration and microbial activity. Plant effects, 27% more root mass. We'll show you some pictures how the root mass improves. So you have at the final, what we call as the outcome on the matrix is 10 to 15, 10 to 25% yield increase depending on the crop and depending on the area. You could get 20 to 30% lesser water use. You can reduce the water consumption. You have 25% reduction in fertilizer. Slowly the fertilizer can be removed, so you can move towards organic farming. Then you have 10 to 15% faster harvest. Return on investment is 1 to 2 seasons normally. So whatever you invest in a nanobubble generator, that money comes back because you have increased yields, water removal, reduce in fertilizer, etc. So same thing we have shown again. Pathogen, aeration, yield, root mass, I've already discussed that. Reduce soil compaction. So because the nanobubble goes and have cavitation effect, so the compaction of oil of the soil is reduced. So more airy it becomes and more breathing the soil becomes. Pathogen suppression, 74% reduction in Pythium and Phytophthora root rot incidence has been noticed. All these are documented and published papers. We are giving the references at the bottom. Enhanced nutrient uptake improved nitrogen, phosphorus, potassium availability at the root zone. So starting from the seed germination point, using Nanoporex nanobubble water enhances oxygen availability. Higher dissolved oxygen levels accelerate metabolic activities in seeds. Promotes uniform water uptake essential for consistent germination. That means the losses you can get sometimes during germination of seeds, that is drastically reduced, and you have a very healthy plant growing from the very beginning. So you can start using nanobubbles right at the seed germination stage. Faster germination, uniform crop establishment leads to healthier plants, reduction in germination failures caused by anaerobic conditions. Like when seeds are kept together or nearby, you have anaerobic zones. So this water does not allow anaerobic zones. It is always oxygenated. You have enhanced nutrient uptake. Because of the soil characteristics changing because of nanobubbles, you have oxygen enriched irrigation. Water promotes root development and nutrient absorption. High dissolved oxygen levels improve aerobic conditions in the root zone. Reduction in toxic compounds. Like I showed you in the beginning, that bubble had reactive oxygen species at the surface. It had a negative charge. That means the potential of making these hydroxyl ions around that. So what happens is it immediately goes and attacks the toxic compounds. For example, there are organic, now these days chemical contamination is there, drugs, in trace levels, ppm, ppb levels, they are coming in water. So these are destroyed by this water, so that plant does not get affected. It creates a very healthier environment of the roots and preventing nutrient inhibition. Facilitated nutrient solubility and mobility. What does it mean? Aerobic conditions prevent nutrient precipitation, keeping them bioavailable for plant uptake. So bioavailability of any nutrient is very essential for a plant. Oxygen nanobubble enhances breakdown of the organic matter, releasing essential nutrients like nitrogen, phosphorus, and potassium, which becomes bioavailable now to the plant. It improves the root and health and growth of the plant, right? You can see the pictures here with and without water, how it looks. So you have the oxygen nanobubble irrigated water on the left hand side, and on the right hand side you see how the roots have grown, how the cluster of the roots has increased. Deeper and more extensive root system increases. Oxygen enriched water stimulates root elongation and proliferation. You can see that it penetrates deeper and deeper. This is very easily visible in hydroponics, where you can actually see the root very visibly. So there you see long roots coming. Nanobubbles create an oxygen-rich environment that supports beneficial soil microbes. Okay, soil microbes which are aerobic in nature. The anaerobic bacteria, the pathogens, get killed because of the rich oxygen content. But simultaneously, what happens is the microbes which need oxygen to grow, which are known as aerobic bacteria, they get an oxygen rich environment, and it supports the growth of these microbes, which enhance decomposition, is stopped, soil structure and aggregation, disease suppression happens. So these are decode six, all the six factors which take place. These microbes aid in nutrient cycling and fixation. Enhanced oxygen delivery to the soil. Nanobubbles dramatically increase the concentration of dissolved oxygen in irrigation water. Water infiltrates the soil, and like I told you, the cavitation effect goes and opens up the soil. This addresses oxygen depletion caused by soil compaction. So you are aware that when you do irrigation, slowly the soil starts getting compacted, and you will see that you have to do tilling of the soil for it to pick up air. Whereas in nanobubble, what happens is when you do irrigation with that, it keeps the soil open. Okay, so the compaction is minimized. Anaerobic zones are removed. Improved soil structure and porosity. So microbes supported by nanobubble oxygenation produce polysaccharides and organic acids that bind soil particles together, improving the soil structure. You see that everything is happening like a chain reaction. Moment you are changing the environment in the soil. Reduction in soil compaction. Better soil structure means better breathing of the plant and better plant growth. Oxidation of harmful compounds, I already discussed that. Agrochemical use. Now, a lot of fertilizers are being used these days. Nanobubble produces this reactive oxygen species through mechanisms such as bubble collapse, external simulation, and UV light. The moment the UV light from the sun comes in contact with this water, irrigation water, it creates further species which are oxidizing. And these act as natural disinfectants. So the agrochemical is used, reduction is reduced. These disinfectants, the natural disinfectant which is created around the plant, kills the suppressing harmful pathogens. Already discussed. Reduce pesticides and fungicides, same mechanism. So you will see over a period of time, if you continuously use the Nanobubble, Nanoporex system, you will start reducing your pesticide intake. You will start getting less diseases in the plants, and you can also spray this water on the plants. You can have irrigation, drip irrigation. You can have flood irrigation. Example for rice. I'll show you a case of rice where anaerobic zones create problems with the rice agriculture. So there you create an aerobic atmosphere in the water. Prevention of disease, hypoxia, which is called shortage of oxygen, and root rot. This root rot is a common problem in these plants. Sustained oxygen delivery from nanobubbles ensures optimal soil aeration. Nanobubble prevents formation of waterlogged, oxygen-deprived zones where pathogens thrive. Faster decomposition of organic matter. Now made for Indian crops and seasons. So what we have done is, there are some cases from Argentina, some from Chile, China, Japan, India. So there are a couple of cases, but Indian crops like rice, wheat, tomatoes, cotton, vegetables, sugarcane, effective in monsoon floods and summer heat also. It works all the year round. And from Punjab canals to Maharashtra, Tamil Nadu, greenhouse and ponds. It is also used in, apart from agriculture, it is also used in aquaculture. So whoever is doing aquaculture, prawn culture, it is very, very beneficial there. So I don't know whether we have any slides for that in this presentation, because we are focusing more on agriculture here. So these are the plants you can see where it has been used, and they have shown good results. In India, tomato pilots, more fruit, less rot. You can see a 20% increase in the yield composition per hectare. And in China, you can see 16 to 19% yield in a greenhouse. 30% water reduction in trials has been noticed. This is a hydroponic for lettuce. Some cases from Belgium, some Israel, wherever they have used nano bubbles. They have, in Israel, you can see the weight of the lettuce increased per head, then by almost 50 grams. You can see without hydroponic, standard hydroponic, and with nano bubbles, there's an increase of 45 to 50 grams per head, and there is a weight gain, and it grows 3 days faster. That means the yields are faster, so you have more cycles coming in. In Nanobubble in Belgium, there was a yield increase of 11%. In US, 25% increase was seen in hydroponic cases. So all these hydroponic, wherever you're growing like cherry, tomatoes, lettuce, basil, all these plants can use nanobubble, and it reduces also the diseases by almost 50 to 70% in these waters. Here I forgot, there is a aquaculture also. So there is a case study of aquaculture integration. So this is one is in India, another one is in Vietnam. Vietnam is a fish farm, and you can see the growth rate using water is almost relative. From 100, it is becoming 140. Disease incidence has reduced drastically, and dissolved oxygen has shot up. So more oxygen you give to these these fish and aqua species, you get 40% more yield from the pond. So we have some very good documented papers for this. Then we have a 50% more yield from, because our yields right now in India in the aqua farms are very, very low. There is a huge possibility of growth, and this can happen if we start using Nanobubble. These are not expensive to implement, but they give tremendous results to the farmers. And you have 85% oxygen transfer efficiency increase. So boosting crop yields, you can see with nanobubbles, enrich crops like coriander, turmeric, basil in sustainable zero waste, shorten the growth cycle. That means more yield, more number of plants you can sell, increased oxygen levels, and improved plant health, healthier plants and a quicker path to market, improving profits and efficiency. You know that if you take a healthy plant to the market, it is immediately picked up, whereas a shriveled plant, people don't even look at it. So this is what the nanobubbles do to plants. They are like, as good as they are living beings. So if we get the right nourishment, we look very hale and hearty and healthy. And if we don't get, we become shriveled and old. So same thing happens to the plants. So we have to give them good nourishment. And this is in terms of just natural way. We're just using natural resources and changing the environment of the plants. Enhanced beetroot growth. You can see that. So this was a study in, I think this is a Chinese place. Nanoballs increase the oxygen in the rhizosphere root area, promoting plant growth and nitrogen use. Improved, again, lettuce wet yield was increased. Tomato, cucumber crops, these again are classic cases where nanobubbles can be used. Rice cultivation, like I told you, the use of nanobubble increased the grain yield of early rice by 4.84% to 10.95, and the late rice by 6.2 to 14.3. You almost 3 times in one case and almost 2.5 times on the other one, which means a huge profit to the farmer. So return on investment for the farmer is sometimes not. We are also looking at certain bank facilities for the microfinancing for farmers. That also is in talks with certain banks and some microfinance companies. But for FPOs, they can directly go in for a equipment like this. We could set up a demo for them to see the performance in the first 2-3 months for short period plants, and then we can go into the bigger. These can be discussed on a case-to-case basis. Improve nitrogen efficiency and enhance root characteristics. Sugarcane cultivation. This is a Chinese sugarcane cultivation. Now we have a pilot running in the north of India, where we are going to be showcasing our nanobubble generator. We are working on 10-hectare sugarcane plantation, and this farmer or this farming community has more than 1,000 hectares. As 1,000, I think 1,000 farmers are there, and conglomerate is going to implement it if the results are good. And we are very confident about the results. We should be able to give you the Indian results in the next season, not right now. But China has shown already very good results in sugarcane, and this is the output. Hydroponics, like I have been telling you again and again, you can get very good results, shorter to the market, go to market can be shorter. Proof in numbers is that the return of investments can come in 1 to 2 seasons, depending on the size, the type of plant, and what kind of growth the plant can take. So the plant yield can increase anywhere from 10 to 25%. Wherever they are paying for water, if at all in India that is not the case, but 20 to 30% reduction in water is there. Even not if you are not paying also, but from a environment perspective, if we can reduce the water consumption in this country, we can do a lot to the environment, because water is going to be a scarce commodity over the years. Then 10 to 25% reduction in fertilizers and chemicals. That is a huge reduction. As it is, we are overdoing the use of fertilizers and chemicals in this country. So a more sort of aware approach is required to bring in some sort of discipline in fertilizer use. But fertilizer companies, they are really not working very hard on this, and they are dumping chemicals in the plants, which is also degenerating the soil. So indirectly you will be doing a favor to the mother earth by going with natural methods. Then you have healthier plants and environment. That is the end result of this. Technical implementation specifications. uh, Target water parameters which we can achieve are 15 to 30 ppm. Normally, sometimes some of the farmers don't even get 1 to 2 ppm. That is, the plants don't really grow very healthy. Our yields compared to the world standards in any plant you take, sugarcane you take, we are hardly 75 tons, whereas the world standard is 140, 150 tons. So we are almost half of the world standards. Various plants, if you see the world standard and where we are, and if we can do slight changes in our thinking by bringing natural modes, we can really make a big difference to our farming. Sizing by application flow rate power 1 hectare, rice, wheat, you require around 10 to 20 liters per minute and about 1 to 2 kilowatt for 5 hectares. When you look at these kind of wattages, these are like running a small heater or small fan in your house. It's not really very high on power consumption. The whole thing is the chemistry and the cavitation effects and the system which is creating this magic. The installation costs can vary from 50,000 to 2 lakh rupees depending on the size of the farm and the type of the farm. And the return on investments can be in the range of 6 to 12 months. For smaller farms, the cost could be less than that, less than 10, 20,000 also. We are trying to subsidize these as much as possible for farmers so that more and more farmers can utilize them and take benefit of this. So we are now designing a 10 to 20 liters per minute model, a small portable model, which can go from farm to farm, let's say a cluster of 10 farmers. So they can use in turn. So 10 farmers can collectively buy a machine of 50,000, which is only 5,000 per farmer. And they could, use it every hour. They can transport it from one farm to the other. So these kind of models can be worked out. This is the ROI calculator. We will go into details. So in summary, what I'm trying to say is we are increasing the water efficiency in water irrigation, 10 to 20% improvement, chemical reduction, lower fertilizer and pesticides usage, carbon footprint, enhanced soil health, and farmer empowerment, which is the most important thing which we are targeting. Our purpose is we have also a finance company where we are working on agri-tech businesses. All farmers who are coming up with some new ideas, there we support them. So in farmer empowerment, increased incomes and resource sustainability is the final goal. If we are aware that a lot of farmers are passing through bad phase financially, and if we can reduce the costs, improve their yields, increase their profitability, it will be some contribution from our side to the society. So these are some research papers. And to give you a little bit of background on our company, we are a process engineering company. So agriculture is one of our domains. Then we have solid waste management, where we do composting. We make continuous composters. Then we have wastewater treatment for industrial applications, where we do toxic wastewater treatment. And there is a separation science division, which totally takes care of industrial uses, basically. So these are the three divisions: filtration and separation, wastewater, process design, and agriculture is the nanobubbles for agriculture is what we are giving. So with this, I end the presentation. Like I was told that to cover it in about 30 minutes, so which I have done. And I'll be very happy to take any questions.
Thank you, Mr. Lalit, for the presentation. Now I'll take up some questions. Just 1 second. Okay.
Hello?
Before I take up some questions, I would like to check.
They could have given the question in the chat box.
Yeah. So first question is, how does Nanoporex nanobubble technology differ from traditional aeration or oxygenation methods used in irrigation water?
Yeah. So typical aeration and oxygenation methods, the oxygen does not get retained in the water. Okay. Whereas when we make the same oxygen into a nanobubble by the nano generators, it stays in the water for weeks together. That means the capability of it to transfer the oxygen at the root level is 70 to 80% higher than the normal aeration. Does that answer your question?
Okay. Yeah. Okay. And what gases typically used in nanobubbles and how do they benefit soil health and plant growth?
Come back again.
How gases are typically used in nanobubbles and how do they benefit soil health and plant growth?
Right. So like I told you, these gases become very reactive because of the nanobubble size and the surface tension inside it has a charge on the surface. So when you use, like we can use oxygen, they have used hydrogen, they have used carbon dioxide. In USA now they have used nitrogen, all in situ, in irrigation. And everywhere they have seen different results. So whenever there is a nitrogen requirement in a plant, they are using nanobubbles of nitrogen mixed with oxygen, like typical air. Just air, if you send, it is 70% nitrogen. But if you send pure oxygen into the nanobubble system, then your aerobic atmosphere environment totally changes and becomes very good. Okay. And with CO2, it's an organic and the plants are made of carbon, right? So that goes and starts reacting with the microbes at the soil level. Some very interesting papers are published by putting CO2. They have seen some good results in the plants. So different gases have different results.
Okay. Can you explain the mechanism by which nanobubbles improve nutrient uptake efficiency in crops?
So if you look at medical science today, you know, you must be reading a lot that a lot of drugs are coming uh, as a nano drugs, nanoparticles. Why do they make drugs particles? So that we consume? The nanoparticles create a very high surface area, okay, and they are consumed by the body immediately. For example, if I give an oxygen bubble on the surface of the plant, half of the oxygen will be removed, will just go away. Some will remain like molecular oxygen on surface. But whereas if there is water, moisture, and the bubble is held by the moisture inside, it stays close to the what, and it makes the oxygen bio available to the plant. it goes through the capillaries and the plant uptake is very good when it is in a nano level. So that is why, like you are aware of fertilizers also now. The whole country is now talking about nano urea. What is the difference between nano urea and normal urea? Large particles of urea were being used in the farming. Why suddenly said nano urea? Now, moment nano urea came, your consumption of urea reduced, uptake by the plant improved, nitrogen availability became better. Why? It was in the nano size. Similarly, when you make oxygen available in nano, then it becomes a better for the plant.
Right. Okay. Now, what type of crops or farming systems, that is example, horticulture, hydroponics, paddy or greenhouse, have shown the best results with this technology?
Yeah, I think we showed you quite a few. So hydroponics has shown very good results. Tomatoes, tomatoes and lettuce, the vegetable section side. Then sugarcane, the results are very good. We are still working at one of the farms in north of India. We will be coming with the results very fast. Rice shows good because rice, the water being stagnant creates a lot of anaerobic zones. And when you have aerobic water, that is aerated water, very stable oxygen availability, the anaerobic zone disappear from that water. So your rice cultivation becomes much more better, which in turns affect the produce. So these are the basic crops.
Okay. Mm. How can nanobubble treated water help reduce fertilizer or pesticide use in sustainable farming practices?
Sorry?
How can nanobubble treated water help reduce fertilizer or pesticides use in sustainable farming practices?
Right. So, what does a fertilizer do, or what does a pesticide do, or what insecticide do? Basically, they create an atmosphere which kills the pathogen, which kills the species which is harming the plant. Now, how does it do? Sometimes it is done chemically, which also negatively affects the plant. But when it is done naturally, that means when you put a nano bubble in place, nano bubble, like I showed you, was a bubble of oxygen at 100 nanometer size with reactive oxygen species on the surface, a negative charge. Now, these negative radicals create OH radicals, and they in turn go and break all the toxic compounds around the plant. They actually degrade them, and because the nanowall oxygen is available in those areas, the bactericides which you would be putting to kill the anaerobic bacteria, this kills because you create an aerobic atmosphere in the. So we try to create a conducive atmosphere for the plant to self heal itself. You have natural forces healing the plant rather than extraneous chemicals and biocides and all these coming, which cost no doubt, but also indirectly deteriorate the soil quality, leave traces on the plants. Quite a few pesticide traces are retained on the fruits and certain teas and etc, and we are having exports being returned to India. Why? Because some of these pesticides are poisonous, and even the trace element left on the plant is not allowed. So many shipments came back recently, so it is going negative toward to the country. So if you can use more methods which are more sort of friendly, nature friendly, environment friendly, then it makes sense. So it definitely reduces it does the similar job like a pesticide or a fertilizer, because it makes the nitrogen, phosphorus, like I told you, potassium, bioavailable. By breaking certain compounds, these are available to the plant then. So everything is there in the Mother Earth. Only thing is we don't know how to use it. So if we create an atmosphere which is conducive for something to happen, it is a symbiotic action the plant starts taking. Where did we have fertilizers maybe 100 years ago before World War? Where did we hear of any fertilizer in this world? No. Everything was grown organically. Where did these fertilizers come from? Because we made enough chemicals during the World War, we didn't know what to do with them. So we started pushing them into agriculture. So it is the science which has messed up our us. So we need to retract, we need to go back in times and start thinking what was that which was good for us. And these are the natural ways to do things, you know.
Okay. Is this technology compatible with organic farming systems?
Definitely. It is definitely because it is not giving any chemical to the soil. It is not giving any pesticide to the soil. It is natural. We are just enhancing the way it is delivered to the soil. Nothing else. It is the same air, same oxygen which is there in the air which the plant is already taking. So in organic farming, we are aerating the irrigation like you already told. So this is also another way of aeration, but it is a much more advanced way. So we are creating this nanostructure, which is a much more advanced way of aeration and more stable and more sustainable way of doing it. It is definitely very conducive to organic farming.
Okay. How does nanobubble irrigation affect soil microbial activity and root zone aeration?
I think I've showed you enough slides on that, but I'll again repeat. Uh, so the microbial, there are two type of microbes. One which are known as hypoxic zones when they grow, which are harmful to the pathogenic bacteria, what are called. They are harmful to the plant. And other one are the benign ones, which are the aerobic bacteria, which are available. If you just take a little bit of soil and get it tested, you'll get millions of bacteria there. Millions, I'm saying. Okay. That's why you say now that a child should go and play in the mud because that bacteria also helps his gut. So indirectly, our gut also gets supported by this bacteria. These are very benign bacteria. So what does nanobubble do? Nanobubble goes and creates that environment which is helpful for the aerobic bacteria to grow, to proliferate properly, and create an environment which is good for the plant. And the pathogenic bacteria which don't grow in oxygen, they normally propagate in anaerobic zones. So whenever you have soil compaction, that time anaerobic starts. If you pick up the soil in certain areas, you will see some sort of different type of fungus is growing or it is smelling. So those things will not happen because bubbles, when they go inside, one, they diffuse the oxygen to the plant. Second, because of the cavitation action, certain bubbles break and they create very micro explosion inside the soil and they open up the soil. So it does not stay compacted, but it stays open. It breathes not only natural air, but it also breathes the oxygen being diffused from the nanobubble itself, from the irrigated water. So this serves two, three purposes in all.
Right. Can nanobubbles help in reclaiming saline and alkaline soil or alkaline soils?
Uh, Answer to this is, I think no, because it does not really help too much on the inorganic salinity, because the salinity is something which stays in the soil always, and that is always a challenge. So the plants which can grow in saline atmospheres are normally grown over there, but it does not really affect the salinity.
Okay. And what is the impact of nanobubble water on, sorry, I'll repeat it. What is the impact of nanobubbles water on water retention and soil structure?
Yeah. So water retention will be there, but in a very open way. The soil will become open. You will see a very porous soil, not compacted soil. So the the movement of the oxygen through the water will be there, and water retention will not be there to that extent, but the soil will remain moist because of that. It will not that it will become flooded. When does it get flooded? When there's compaction. When the soil gets compacted, the water does not have any movement. But when the soil is open, you have movement of water. So that is where the nanoballs will help the soil overall. Soil deterioration is reduced drastically, not only by the effect of oxygen, but also effect of the curative action of the oxygen, which kills the pathogens, which kills the harmful toxic compounds which come in the normal water. You are not going to put treated water into agriculture. You'll take river water or some water from nearby. Now these waters always carry some sort of toxins, because most of the rivers are flooded with sewage water these days, right? Because 90% of our sewage treatment plants in this country are not running. So what comes in sewage? Human waste, whatever is thrown from our domestic, and drugs, chemicals, and they come and mix with water, and they are available in ppm levels. Those come to the plant and they start creating problems in the plant. So nanobubble indirectly attacks these molecules which are toxic to the plant, because it has got very high oxidizing capability for organic species like this. Okay.
Yeah. And what kind of setup or equipment is required for farmers to adopt Nanoporex and Nanobubble systems?
So most of the places where you have a pumping mechanism, which is taking water either through the drip irrigation system, or if it is flooded, then through that system, we just have to put one device in between the pump and your delivery point. So normally these pumps have a head of about 20-30 meters, 15-20 meters. So we can design the our equipment in such a way that it will give you water at that pressure, so that you don't lose head also. Normally around 5 meter head is lost in this system.
Okay.
There's not very difficult. In between the pump and the delivery point, in between that pipe, you have to install it.
Okay. And what is the cost benefit ratio for small and medium farmers?
Like I showed you, the return on investment, normally depending on the type of crop, it can vary between 1 season to 2 seasons. Now depends again on the season type. Short crops, short time period crops, then you have long period. So it's a very relative question to answer. But for example, a sugarcane calculation we have done, in 2 seasons they will get the money back. Okay. After that, it is profitability. So if they are getting a 20% yield increase, that itself per hectare you can calculate, it more than makes up for the nanobubble equipment cost. So, and we have tried to keep the cost very, very low, because these are available from US also, and the US is almost 10 times our price. Still, it is the US people are buying that equipment in USA, and they are saying return on investment is very good. So you can imagine with our pricing how it will be for the Indian farmer. So we have to do everything considering the Indian farmer, because he cannot afford very high prices. So because of that, we have done the design in such a way that we can minimize the costs and try to maximize the profit for him.
Okay. And what is the cost benefit ratio for small and medium farmers?
Small and medium farmers, maybe 6 months, they would recover their cost.
Okay. And how much maintenance and power does the system require for daily operation?
Yeah, so I told you it's like running a fan in your house, on a per acre basis. So normally it is around 1 kilowatt. Normally motors running are 15-20 kilowatts also sometimes in some farms. Here this is only 1 kilowatt. That is if we are giving the water. If you already have a pump in place for pumping your water, there is no power requirement. The power requirement is only for pumping the water. So if you have a pump in place which is already pumping water, we just have to put a static device in between, which will create this nanobubbles, because we will be putting cavitation, and maybe about hardly 300 watts, 0.3 kilowatt power extra will be required.
Okay. Can you share field trial data or case studies where Nanobubbles technology significantly improved yield or quality?
Yeah, we can share it. I can send you some information later, which you can
Okay.
distribute to your members.
Okay. And how scalable is this technology for large farm holdings or community irrigation projects?
See, like I told you, the sugarcane. Now, sugarcane is very large scale agriculture. There we are talking of almost 200 meter cubes of water going per hour. That is 2 lakh liters per hour. Whereas in a small farm, it could be only 500 liters per hour. So we have all types of designs. So we basically design based on the flow rate, or if you can tell us the pipe size. So if there is a 1-inch line, 2-inch line, 4-inch line, 12-inch line, so we can design it for any pipe size. I
Okay.
don't know whether I could have shown you something. A large pipe size I could have shown you if you wanted. Would you like to see an installation?
Yes, you can show.
Let me see if I have it here. That's a large scale installation. Okay, I will show you a couple of them. Now you see this is, can you see?
Yes, 1 second. Yes.
So this is a small, this is a device in line you have put. Then this is another device. It is put on the pump line. Now this is for a 10-inch line. When you are doing farming in a 10-inch line, so this is the equipment which is used. So it's for a bigger pipeline, the installation becomes big, and you see at the side you can see a 27.7 ppm of DO level, oxygen level. Okay.
Yeah. Okay. And how scalable is this technology? Okay, you have already answered. What future innovations are being explored in nanobubble applications for agriculture?
Yeah. So we are working on now integrating this with the ultraviolet, then integrating this with plasma. Now, what does plasma do? Plasma creates online nitrogen source. That means it converts the nitrogen to ammonia or a nitrate, which goes directly into the plant. So with the nanobubble integrated with plasma, we might be able to remove urea purchased by the farmer. That is my next target. This has not happened anywhere in the world, but I am working on that in our lab. And if that works, it will be wonderful. So that is another. Then we are trying to put charges on the water, further charge. We are also introducing certain electrical conductive charges in the line, but that is for very, very sophisticated farms. I don't know, this is a project which we are doing somewhere in South America, but in India, the farmers are not that literate, so we might not be able to introduce that in India as yet. But outside India, yes, we are looking at some very, very creative innovations.
Right. Okay. Okay. So before we wind up, I'll check with Mr. Srinivas if you'd like to ask any question. Mr. Srinivas, you can post your question in the chat box or you can ask directly.
I don't have anything. Thank you.
Okay. Okay. Okay, Professor Lalit. So I don't see any more questions. So now we have come to end of question round. On behalf of agricultureinformation.com, we'd like to thank you for a very detailed presentation, answering all the questions in depth. So we'll be ending this meeting now. Thank you.
Thank you very much.
Yeah, thank you. Thank you, Mr. Srinivas.
Thank you.